Welcome to my channel AAA Encyclopedia, and in this video let us see what is current divider rule or current division rule, and also voltage divider rule or voltage division rule. So these two rules are most commonly used while solving the problems comes under power systems and also circuit analysis. So these are all the basic rules at the time of finding the current in a branch or voltage across the particular resistance. We can directly use these two rules. Okay, so now let us see. So what is current divider rule and current division rule? So mostly this current divider rule is used in a parallel circuit. That is, the parallel circuit, normally the current is divided according to the value of resistance in each branches, and the voltage in that parallel circuit remains same. So here the current division rule determines the current in that particular resistance or impedances. So the current divider rule is nothing but the current in a particular resistance in a parallel circuit is equal to total current in the circuit into the opposite resistance. That is, if you want to find the current flowing through the resistance R1, means what is the resistance opposite to the resistance R1, that value should be present here, divided by the total resistance of the particular parallel circuit. So the current divider rule is used to find out the current flowing through a particular resistance. So this is the current divider rule. And now we just take this parallel circuit. In this circuit, this is the voltage applied to the circuit, and the total current flowing through the circuit is I. There are two resistances, R1 and R2, are connected in parallel. So the current flowing through the first resistance will be I1, and current flowing through the second resistance will be I2. So in the parallel circuit, the voltage in each branches remains same as the applied input voltage. So already I said that what is the current divider rule? It is nothing but we want to find the current flowing through a particular resistance, right? So now I have taken the current I1. That is, we want to find the value of current I1 flowing through the resistance R1, so that this is the unknown value, right? So which is equal to, what is the formula? Total current in the particular parallel network is I into, so I1 is the current flowing through the resistance. This is the requirement. What is the resistance opposite to this R1? It is nothing but R2. So the total current into the resistance opposite to the R1 is what? R2, right? Divided by the total resistance in that network is R1 plus R2. So here we should not apply the parallel combination of resistances, just add the number of resistances in a parallel network, that is the total resistance. Suppose if I want to find the current flowing through the resistance R2, what will do? I2, which is equal to, there is the current flowing through the second resistance R2, which is equal to total current of this network is I into, what is the resistance opposite to R2? So this is the requirement, I2. It is the current flowing through the resistance R2. Opposite to this resistance is what? R1. So the total current into opposite resistance R1 divided by the total resistance of the parallel network R1 plus R2. So this is the simplest way of finding current flowing through the branches of a parallel network or a parallel circuit. And next one is the voltage divider rule or voltage division rule. So the voltage division rule is applied to the series circuit. So previously we have seen that current divider rule is applied to the parallel network, but here the voltage division rule is applied to the series network. So in a series network, the voltage is divided and the current remains same, but in the previous one, the current will be divided and the voltage remains same. And this rule is used to identify the voltage in a particular resistance or impedances. So this is the voltage divider rule, right? Okay, so now for that, let us take the series combination of resistance in a network, that is the voltage applied voltage B, and the current flowing through the network will be I. The resistances R1 and R2 are connected in series. So the corresponding voltage across the resistances are V1 and V2. So already said that in the series network, the current remains same, but the voltages are divided according to the value of resistance in the particular network. So the voltage divider rule is nothing but voltage across the particular resistance, which is equal to what is the total voltage applied to the network into the same resistance value divided by total resistance, right? So take this network. Suppose if I want to find the value of voltage across the resistance R1, means how to find out the value, right? So the V1, which is nothing but voltage across the first resistance otherwise VR1, so which is equal to, what is the total voltage of this network? V, right? So total voltage is V into, so where we are going to find the voltage? Across the resistance R1. So we want to take the same resistance value R1. So the voltage across the R1 means we want to put the same resistance value here, divided by the total resistance of the series combination of resistances R1 plus R2. Suppose I want to find the value of voltage across the resistances 2, right? The second resistance. What is the voltage across the second resistance? Which is nothing but, in this network, the total voltage will be V. So we want to find the voltage across the resistance, this one, so that the corresponding resistance value is what? R2. So that total voltage into the same resistance divided by the total resistance of the network. So this is the formula for a voltage divider rule, and this is used to find the value of voltages across the separate resistances in a series network. And now let us see the summary of this concept. The current division rule is nothing but the current flowing through a particular resistance, which is equal to the total current into opposite resistance divided by total resistance. This is the important formula. And the voltage division rule is nothing but the voltage across the particular resistance is equal to the total voltage into same resistance divided by total resistance. So here total current, total voltage, but in the current divider rule we want to use the opposite resistance value in the numerator, but in the voltage division rule we want to use the same resistance, that is at which resistance the voltage we want to find is put here, right? That is the if you want to find the voltage across the resistance R1 means we want to put the R1 value here, but if we want to find the current flowing through the resistance R1 means the opposite to the R1 resistance, that should be present here. That is the numerator, we want to put the opposite resistance. So these are all the two important formulas. These formulas are very necessary for solving the Thevenin's theorem and many problems in that circuit theory, and also the power system, and also the transmission distribution. Also we are having more number of problems, so that these formulas are used to solve that particular problems very easily. Okay, thank you for watching. If you are new to this channel, kindly subscribe our channel AAA Encyclopedia, and share all basic concepts of this channel to your friends also.